A means of mass production of glass strands is accidentally discovered in 1932 when a researcher at Corning Glass inadvertently directs a jet of compressed air at a stream of molten glass and fibers are produced. In 1935, Corning Glass joins with Owens, Illinois, which is also experimenting with fiberglass. The word fiberglass, with one S, is patented in January of 1936, and the two companies merged, resulting in the creation of Owens Corning in 1938, adding to Toledo's claim as being the glass capital of the world. In 1941, Owens Corning, spurred by World War II's demand for lightweight aircraft parts, begins weaving glass fiber for commercial use. Simultaneously, DuPont creates and is awarded a patent for polyester resin in 1936. Refining its curing process, American Cyanomen produces the direct forerunner of today's cold-setting polyester resin in 1942. Also in 1942, Ray Green, working in Toledo, is building small wooden sailboats and also doing some experimental work for Owens Corning. He combines weaved glass fibers with a laboratory sample of polyester cold-setting resin, building a sailing dinghy, reinforced with glass. After returning from the war, serving as a commissioned officer in the Navy, Ray resumes his boat-building business and in 1947 introduces the Rebel, a 16-foot fiberglass hull wood deck sailboat, to the world. Not only is Ray Green credited with being the first to build a recreational boat out of fiberglass, by 1949, Ray believes he is the largest fiberglass boat builder in the world. His family calls him Jim, but to virtually every Interlaker he is known as Vince. His background is chemical engineering, earning a degree from Rhode Island University. Working for Monsanto Chemical, he invents and patents a product called Sanasil, a second-generation filler for fiberglass resin, the first being clay. In 1950, he arrives in Toledo to work for Libby Owens Ford as a sales engineer in the newly announced Glass Fibers division. Quickly, after coming to Toledo, Vince becomes a proud owner of Interlake number 67, and in honor of her 930-pound weight, appropriately names her Cement Barge. He participates racing his boat at occasional Toledo weekend regattas against 5 other Interlakes. To augment his craving for greater racing opportunities, Vince accepts an invitation by Fleet No. 1 members Paul Coe and Norm Winkle to join the 27-boat Interlake fleet that sails local races on Wednesday nights. Each Wednesday, Vince tows the cement barge to Sandusky and back for the honor of consistently nailing down last place. Convinced the heavy boat, not the nut on the tiller, is responsible for always finishing last, Vince, in the late fall of 1952, starts building Interlake number 157 in the basement of his house. Due to the home's location on the side of a hill, removing the boat will necessitate modifications to a basement wall. Fortunately, compared to his racing performance, professionally Vince is enjoying better success. However, he is captivated by the idea of being his own boss and starts a business refurbishing small boats. One night, a sailing buddy, Charlie Schneider, and Vince go bowling. Vince is introduced to Charlie's brother-in-law, Norm Miller. Norm is also presently engaged in a self-employed business refinishing desks and chairs for the city's Board of Education. After some discussion, they decide to form a partnership combining assets, mostly consisting of woodworking tools and about $350 each. They call their new venture Custom Products, and in the first year they produce revenue of approximately $350,000. While the new business is going great, it is not providing much extra time to sail or work on number 157. When the Interlake finally reaches a point in construction where it can be removed from the basement, Vince's wife Barbara votes down his idea of demolishing the house to get the boat out. Bill Mills buys the boat where is, as is. Vince and Bill disassemble number 157 piece by piece and reassemble it in a rented garage. Interlake number 157, sailed by Tom Taggart, wins the Nationals in 1964. In the fall of 1954, fellow Interlake sailors Bob Marone and Bill Schroeder talked to Vince about attempting to build a glass Interlake. Vince agrees and is intrigued by the possibility that he may be able to build a boat weighing significantly less than 930 pounds. He is met with some trepidation by his business partner Norm Miller, who fortunately eventually agrees to the project. Vince is acutely aware that wood sailboats need to be wet sailed to stabilize the swelling characteristics of wood. Decks typically covered with canvas also contribute to a boat picking up 60 to 80 pounds in a season, soaking up fresh coats of paint and water. Fiberglass boats do not need to be wet sailed and routinely painted, further reducing the overall cost and burden of ownership. Now that the Depression and war are over, folks are becoming more mobile. Home-built wood trailers that are not specifically designed for over-the-road transport are being replaced by manufacturers building over-the-road steel boat trailers. 10 plus years after the war, small boat sailing is becoming a very popular water-related leisure activity, especially on many inland lakes that have a maximum 10 horsepower limit for power boats. For whatever reason, one thing is for sure, Ray Green is proving there is definitely a market interested in the qualities of strength, lightness, and reduced cost in hull construction using fiberglass cloth and resins. He is manufacturing and selling what are being referred to as plastic sailboats at a remarkable rate. The next step is to meet with Interlake Sailing Class Association members to present the idea to them. A meeting is set up at the Toledo Sailing Club with approximately 16 attendees. Knowing that questions will be asked pertaining to aspects involving maintaining one design characteristics of a wood boat versus a glass boat, Vince goes on for about 2 hours talking about the advantages of building a glass boat over a wood boat. He attempts to dazzle the gathering, talking about the properties and parameters of gel coats, wax, polyester resin, cobalt, styrene, and peroxide. The audience is having a difficult time, even grasping that the first step to producing a glass boat is applying the material that is actually the finish coat. With heads now bobbing, Vince remarks that when the product is removed from the mold, it is exactly duplicated by the finish of the mold. So, the mold has to be finished to a very high gloss. If it isn't, the product will pick up any mold blemish, even the size of a fly turd. This wakes the place up, and those in attendance vote to give the project a trial run. Vince and some volunteers take his boat number 67, the cement barge that has a measurement certificate, roll it over and strip the hull to bare wood. The boat is then placed under an overhead space heater for the winter. In early spring, Vince battens all the seams and fairs the hull. He seals the wood and then applies 3 coats of copper bronze paint, sanding after each coat. With parting agents unknown at the time, a significant number of buffed out layers of wax are applied, producing a fine finish. Bill Schroeder is present the night Vince decides to lay up the first mold. In today's world, the only concern when mixing epoxy resins is the amount of preformulated catalyst to be stirred into the mixture. In the early years, extreme caution and care must be taken not only in mixing the components of the hardening agent in the right order, but also precisely in the right amount. Do it wrong, and the best that can happen is the concoction will not harden. The worst is fire and/or explosion. Vince stirs the various ingredients, including the cobalt, which is the most dangerous component, and allows Schroeder to add the peroxide to the horrid smelling mixture. Bill's steering technique is not up to Vince's standard, and consequently Schroeder receives a lifelong lesson on how to do it right. The mold is laid up with about 5/8 inches of glass at the keel, stem, chines, and transom. Bottom is about 3/8, and the sides 1/4 to 1/8 inch at the shear. It is then returned to the space heater for about a week. Word spreads quickly that the big day is finally here, and most of the Toledo Interlake crowd shows up to observe the unveiling. Vince takes a saw and cuts the edge of the mold back. Taking a hammer and J-chisel around the perimeter, the shear is forced to separate. Then with everyone grabbing along the edge, lifting and pulling, cracking is heard, but the mold will not release. Vince then decides to drill a hole in the keel and eject compressed air between the mold and boat number 67. No luck. More holes and still no luck. It's a bad night. The next night, Vince attaches a chain to the mold and then uses a hoist to lift the mold and boat off the floor. No success. Bad night number 2. After letting the combination mold-boat hang for about a week, hoping the boat's 930-pound weight might induce separation, nothing happens. Finally, Vince becomes very aggressive. Using a welded chisel on a long bar, he drives the makeshift tool between the boat's sides and the mold. With help inserting chisels around the edges of the shear and pounding on the bottom with a rubber mallet, the desired cracking sounds of separation are finally heard. As one can imagine, the mold is unacceptable as glass adhered to the wood. Not to be deterred, Vince starts the process again. The result is pitted and lacks uniformity. Vince's determination finally brings partial success on his third attempt, but the resulting mold lacks a fine finish. At this point, in 1955, the Interlake Sailing Class Association seeks out Marino Giovanali, a foreman at the Lyman Boat Company located in Sandusky, to build a prototype or plug from which to make a glass boat. Due to the fact that Marino's brethren, Angelo, who wins the Interlake Nationals in 1951, Giovanali is acutely aware that within design tolerances, a flat rocker is inherent to a fast boat. The plywood prototype cost $650, with the class underwriting $400 from its treasury and Vince contributing the balance. The class agrees to allow Vince to keep the prototype. After laying solid fiberglass over the prototype and then separating the layup from the plug, a very successful mold is finally created. Vince immediately continues by reversing the process using nothing but layers of glass and resin. The result is Interlake number 160. The solid fiberglass hull with a wood deck weighs 650 pounds, which is the average weight of the 5 wooden boats sailing in Toledo. Sailing 160, Vince wins the 1956 Maumee River Yacht Club Series, confirming that the nut on the tiller of boat 67 may have indeed been okay. He later states, "I certainly made mistakes. That boat cost me $10,000, but I learned how to build them." Vince sells the prototype to recover some of his costs, and it is last seen with an outboard motor running up and down the Ottawa River in Toledo. Vince DeMayo's sailing success in 1956 results in a line of eager buyers who want a carbon copy of Vince's glass boat. Offering kits at various stages of completion, he prices a complete boat, less sails and trailer at about 2/3 of the $2,400 price of a commercially built wood Interlake. Records do not indicate the actual price of the boat, The earliest Custom Flex price sheet found is in 1961 and shows that a complete boat, less sails, is priced at $16.95. Jib and mainsail, $230, and a gator trailer, $275. Custom Products now has a new subsidiary named Custom Flex. Out of a small building on Oliver Street, Vince continues building Interlakes using solid fiberglass hulls and decks consisting of 5 layers of glass cloth and woven roving, laminated with polyester resin. By April of 1957, 30 boats have been delivered or are on order. Now, there are definitely 2 fiberglass boat builders in Toledo. The Interlake Sailing Class Association responds by updating the Class Revision Committee, formulating a permanent Measurement, Restriction, and Rules Committee. Its purpose will be to It shall also act as an appeals board for questions of rules or class specifications. Norm Winkle takes a very active role in the work of this committee by converting the specifications of the boat from wood construction to fiberglass construction. One of the first issues of fiberglass construction involves stiffness and flexibility. 5 layers of fiberglass impregnated with polyester resin does not provide the stiffness in the horizontal surfaces that is exhibited in boats built out of wood. In other words, the deck and the bottom are too flexible and need to be stiffened. Adding more layers of glass is not the solution, as the weight element of the boat increases dramatically. A solution is agreed upon that the use of redwood or aluminum lateral floor supports shall be attached to the hull with a minimum of 100 square inches of glass per support. These supports shall be covered with 3/8 inch waterproof plywood or planking at least 1/2 inch thick. In other words, floorboards are no longer optional. Deck beams of lumber or aluminum may be used to stiffen the deck. These must be attached with a minimum of 150 square inches of glass per beam, placed a minimum of 16 inches on center. In addition, a minimum of 6 aluminum or wood deck supports must be used from the chine to the deck and must be fastened to the hull with at least 50 square inches of glass and a mechanical bond. Cockpit combing shall be of white oak, mahogany, or walnut, not less than 3/4 inch in thickness. The new specs also call for the centerboard trunk to extend a minimum of 16 inches forward of the centerboard bolt as a mass support and keel load distributor. With Vince leading the way, assisted by Paul, who continues to search and identify the whereabouts of all the lost wood boats, and Norm, working on new drawings, the rebirth of the class is at hand. All 3 are recognized as life members of the Interlake Sailing Class Association. Available records and/or minutes do not indicate the exact time frame the hyphen is officially dropped from the word Interlake. In 1957, Vince refers to the Custom Flex fiberglass-plastic boat he is building as an Interlake. On the other hand, through at least 1959, Paul Coe in his correspondence refers to the boat as an Interlake. Over in Northeast Ohio, in 1939, Gordon K. Douglas, better known as Sandy, pioneers the use of molded plywood hulls for sailboats. The 17-foot Thistle is designed in 1945 and is an immediate success. The 20-foot Highlander is introduced in 1951. In 1956, Sandy decides the time is appropriate to launch a new design, the 19-foot Flying Scot, using fiberglass as a means of construction. This new design features the safety of wide side decks and also a roomy cockpit. Sandy accomplishes this by lowering the inside section of the side of the decks and shapes it into the form of seats, thus combining the advantages of both. However, Douglas is also finding using fiberglass in this fabrication, while offering opportunities, also presents problems. Sandy reaches the same conclusion as Vince concerning the properties of fiberglass compared to wood. Solid fiberglass is denser than wood, so it must be thinner to achieve the same weight. Thinner lacks a stiffness that results in flexibility. Flexing can be the great enemy, since it can lead to cracking. Sandy is convinced, in an effort to add strength without weight, balsa sandwich construction is the solution. Production of the first Flying Scot starts in 1957. Douglas moves his business to Oakland, Maryland in 1958, and orders for the Scot increase at a substantial rate. The desire to continue to expand boat sales of the Flying Scot and establish fleets throughout the country results in Gordon Douglas Boat Company giving licenses to other builders, among them Custom Flex in 1959. License agreements stipulate that the Flying Scot shall be built exactly as she is being built by the Douglas Boat Company. Vince is now confronted with a pleasant problem, as sales and production of the Interlake that is averaging about 50 boats per year has already caused him to seek out a larger building, moving from the shop located on Oliver Street in Toledo to a larger facility at South Avenue and Byrne Road. This new location is literally a stone's throw away from Ray Green and Company. The potential of also fulfilling the additional demand for approximately 50 to 60 Scots a year will require a much larger production facility. The location at 1817 Palmwood provides a structure with a large main bay high enough to accommodate erecting mast on the boats. It is also surrounded by a double mezzanine on two sides, providing storage space for 50 to 60 boats awaiting spring delivery. Both the Interlake and Flying Scot consist of three major components: hull, centerboard trunk, and deck. The difference between the two boats is the Interlake continues to be built using solid fiberglass throughout the hull and deck, while the Scot consists of the balsa core sandwich construction technique in the horizontal surfaces of its hull and deck. In 1960, shortly after building several Flying Scots using balsa as a stiffener, Vince decides to build an Interlake deck using the same technique. The result is a very stiff deck, in fact so stiff that the class specs no longer call for the 6 aluminum or wood deck supports from the chine to the deck. Like the Interlake, the Flying Scot's pear-shaped aluminum rig is very basic and stiff. Both designs call for the mast to remain straight while sailing the boat, and both utilize only 3 stays to hold the mast up. The Interlake specifications call for a box-constructed mast using fir or spruce and a 2-piece T-boom fastened together. The mast and boom on the Flying Scot are extruded aluminum. Vince quickly concludes that by cutting off 4 feet 3 inches, the pear-shaped aluminum extrusion used on the Flying Scot will produce an excellent rig on the Interlake. However, when presented to the Interlake Sailing Class Association, the reaction is not so fast. Questions arise concerning the possible advantage of a different shaped mast and its influence on the wind. Norm Winkle decides the only way to put out this fire is to scientifically test the 2 extrusions. As the non-documented story goes, Norm takes both shapes to the University of Michigan and they are both tested in a wind tunnel. Based on the tests, Norm states that he has good news and bad. The bad news is there is an advantage, but the good news is it does not take effect until the wind velocity hits 75 miles per hour. The aluminum mast and boom are accepted by the class as an alternative, and now will become the Custom Flex standard. However, those preferring wood sticks can still build them at home and use them on the Interlake. In 1963, Vince reports to the Interlake Sailing Class Association the Custom Flex has built almost 300 boats, and the class now enjoys 22 recognized fleets sailing Interlakes. 51 boats compete that year at the Nationals hosted by Clark Lake Yacht Club, Brooklyn, Michigan. At a class meeting in May of 1964, Custom Flex reports to the Interlake class that the builder wants to introduce a new deck configuration to the boat. Specifically, using the Flying Scot deck template, eliminate mahogany coaming and reshape the deck by incorporating molded seats. The second consideration is the elimination of floorboards and supports by utilizing laminations of hardwoods and balsa over the entire bottom of the boat. Vince reminds those in attendance that Custom Flex has previously been using this method of construction on the Flying Scot hull and deck for the past 6 years, and on the Interlake deck for 5 years. DeMeo is convinced that this method of construction results in a hull that is tougher, stiffer, and quieter. In fact, the hull is so stiff that the lateral stringers supporting floorboards can be abolished. In other words, floorboards will be eliminated. He also claims the new design has more room and the chair height seats will provide increased comfort. Vince states that the elimination of the wood coaming will make hiking much easier on the back of the legs, and that the deck should be drier as it will actually be 6 inches wider forward of the jib tracks where water normally splashes. The elimination of the woodwork will reduce maintenance. The cockpit opening of 4 feet by 8 feet will not be affected, as essentially the top of the seats will be nothing more than the lower level of the deck. Vince confirms to skeptics the old wide deck model will still be offered at a price of $18.75, less sales, and the new model will be sold for $17.75, reflecting savings in manufacturing costs. On December 1st, 1965, the dues-paid members of the ISCA vote to approve the 2 new features that are incorporated into the new deck model of the Custom Flex Interlake. Custom Flex markets the new seated deck, calling it the narrow deck model, as the cockpit opening is narrower. The first boat with the new deck is $489, and the last boat manufactured with the old deck is $567. Also in 1965, Terry Kilpatrick, a 19-year-old University of Toledo freshman civil engineering major, starts working part-time at Custom Flex to help pay college expenses. After graduation from UT in 1968, Terry goes to work full-time at Custom Flex. Simultaneously in 1965, the Interlake Sailing Class Association, in an attempt to increase geographic market share, approves a second builder of the Interlake. Located in Phoenix, Arizona, Desert Products, first Interlake number 511 is measured and approved. Dave Shapiro, owner of Desert Products, announces that the biggest change in the Desert Products boat is the addition of a self-bailing feature. He states the floor is of molded fiberglass, extending the full width of the hull and the whole length of the boat. It is supported by liquid foam below and is approximately 3 inches higher than the traditional floorboards, which puts the floor above the waterline. At frame 10, 2 walls are molded into the floor just adjacent to the chines in the bottom. A suction-type self-bailer is mounted in each of these wells and operate very well when the boat is underway. They also act as gravity drains when the boat is lying still in the water. Shapiro goes on to say, A byproduct of the high floor is the ease with which it becomes possible to climb over the centerboard trunk. Boats numbered from 511 to 520 are assigned to Desert Products. (1967) is a monumental year for the Interlake. After approximately 10 years of discussion and many failed votes, the Interlake Sailing Class Association legalizes spinnakers. Adopting the thistle chute, but utilizing a higher attachment point on the mast and a spinnaker pole that can vary from 7 to 9 feet, gives the sail quite a different look from the same sail flying on a thistle. The use of spinnakers initially quietly converts the Interlake from a predominantly two-person to a three-person boat for racing. The introduction of spinnakers excels the boats still equipped with spruce masts to switch to aluminum. Spinnaker poles exert substantial increased pressure on the bow eye holding the spinnaker pole to the mast as compared to a whisker pole simply holding a jib outboard. Screws inserted into wood fibers that have dried over time pull out. More secure fasteners, such as pop rivets, can be used in conjunction with aluminum extrusions to attached hardware. In 1980, the ISCA grandfathers existing boats sailing with wood masts. Newer replacement spars now must be aluminum. In May of 1968, production reaches a peak. Vince reports by May, 96 Interlakes have been sold compared to 62 for the same time period in 1967. He expects to sell 125 boats by the end of the year. Sailors by nature tend to be avid thinkers and oftentimes innovators. As an example, in 1972, a few Interlake sailors interested in increased control of the mainsail replaced the traditional main sheet bridle with a ball-bearing traveler rack. Mounting positions vary from just over the transom to mid-boom. Various mounting positions not only have different effects on controlling the mainsail, but also can significantly alter where fairleads to spinnaker sheets can be located. This development more or less serves as a catalyst for introducing an idea that Vince has been thinking about. Coupled with sales that are showing some decline, in January of 1973, Custom Flex presents to the ISCA the concept of a long-seated deck model. The proposal includes the following: a simple, efficient, rugged traveler, similar to a thistle. Easier access to the spinnaker pole. Easier access to install the rudder. A stronger, lighter, simpler rudder, easily built at home. More room for people with greater capacity. Improved flotation. Competitive sales advantage with other new classes. To put it mildly, the proposal is not well received by the class. The biggest objection seems to be centered on the change shape of the rudder from the traditional beaver tail to a spade shape. Not only is there concern over a possible sailing characteristic change attributed to the new rudder shape, the new profile combines a ball-bearing traveler, necessitating the tiller to be routed through a hole that we cut in the transom of the boat, similar to the arrangement found on a thistle. Obviously, the specifications will have to be changed to allow fore and aft dimensions of the cockpit opening to be increased to just under 11 feet, dramatically changing the traditional look of the boat. The proposal is rejected by the membership at the 1973 spring meeting, but after an intense lobbying effort by Custom Flex, the proposal passes at the annual meeting. Once again, Vince assures everyone that Custom Flex will continue to provide both models as long as there's sufficient demand. The new model becomes known as the long seat deck. In 1974, DeMaio reports that sales of the long seat deck have outsold the narrow deck model by a ratio of approximately 4 to 1. At the 1976 Spirit of 76 Regatta, hosted by Sandusky Sailing Club, Sandusky Bay experiences high winds and heavy seas during the two races sailed Saturday. At least two recent former national champions who have purchased the long seat deck and are sailing their boats with a spade rudder are heard complaining about their boat's performance after the races. The issue appears to be difficulty handling the boats in heavy air and big seas. Both of these very competent sailors experienced their boats falling into irons while attempting to tack. Also, there is concern over water rushing through the tiller cutout in the transom, making it difficult to bail the boat after a capsize. Increased conversations concerning these two topics spread throughout the class, and as a result, sales of the long seat deck drop dramatically. All told, approximately 100 boats are built with the long seat deck, with most hull numbers ranging from 980 to 1100. Class specifications are changed, grandfathering existing spade rudders, but disallowing any new spade rudders that are built. A monumental event occurs in 1975 as Vince DeMaio sells Custom Flex to Terry Kilpatrick. Vince becomes engaged in an enterprise called Thermo-Tru, manufacturing fiberglass doors in the building just east of 1817 Palmwood. In the late 1970s, the era of simply day sailing classic multi-crewed one-design sailboats more or less ends. The economics of fiberglass construction makes cabin-style sailboats with sleeping accommodations more affordable. These boats, often equipped with refrigeration, pressurized water systems, and most importantly, toilet facilities, offer a more suitable choice for many middle-aged sailing enthusiasts who are primarily interested in day sailing or overnight cruises. At the other end of the spectrum, many young sailors, instead of demonstrating tactical racing skills associated with the classic one-design boats, are more or less captivated by the need to go fast. To a greater degree, single-handed sailboats, sailboards, kite surfing, and boats equipped with foils allow athletic abilities to be demonstrated and experienced on the water. Also, certainly not to be overlooked, is the ever-increasing popularity of catamarans among young and old alike. Many of the designs offered do not utilize dagger boards and are very well suited to be conveniently stored on and launched directly from beaches for either a quick day sail or racing. While catamarans typically are not as tactical in nature as monohulls, they are predictably faster. Simply stated, many more sailing choices other than multi-crew one-design classes have become available. With very few exceptions, all new Interlakes and other traditional one-design class boats that are being built in the 80s and beyond are rigged for racing.